Good morning, dear students. Welcome to this digital class of chemistry. And as we are doing our unit thermodynamics, so today I'm going to take the last topic of this thermodynamic, that is entropy and spontaneous processes. Okay, although we will cover our Gibbs free energy also. So let's start with the positive mindset. As the screen is appearing on your thought is appearing on your screen, that is, don't believe in luck, believe in hard work. This is true. Dear students, hard work is the key to success. It means that nowadays, if anything we want to achieve, we need to do the hard work. We need to do our work with sincerity and honesty. The same thing I just want to relate with you. Nowadays, you just not believe on luck. I mean, this because of coronavirus, we are very lucky, and maybe there will be no exam, and we will go through pass. Okay, but let me tell you, if you will going to pass like this way, that success or that result that will not give you that much taste. The taste you will get by doing hard work, and after your hard work, whatever marks you will get, that will really I know that will give you one internal satisfaction. So for that purpose, leave the luck for the God and just believe yourself and do hard work. Okay, so again, the objectives already we have done these things. Introduction we did, definition we did, terms we did, internal energy, laws of thermodynamics. Now we are going to do under the laws of thermodynamics, second law of thermodynamics. Okay, today we are going to do second law of thermodynamics. In that second law of thermodynamics, we will cover free energy also after that conclusion, and this chapter will be over. Okay, so as we already know, we have done 2-3 times the first law of thermodynamics. Some of the students doubt was this. Some of the students asked me to tell sir, enthalpy and enthalpy change we have not got, as I have read in the comment in my YouTube channel. So I'm taking for those students specially. So what is enthalpy, dear students? Enthalpy can be represented with the H only, first thing. Okay, and the enthalpy change will represent with delta H. So enthalpy is the amount of heat. It is the amount of heat stored in a system. Enthalpy is the amount of heat stored in the system. System you know very well now, which is investigatory part. So again, amount is the heat stored in the system under particular condition, that is pressure and volume, which is termed as heat content of the system. मैं बड़ी सिंपल भाषा में बताना चाहूँगा, कोई भी सिस्टम जो जिसमें हीट स्टोर हुआ हो और कितना अमाउंट ऑफ हीट स्टोर हुआ है, जो भी जितना भी हीट उस सिस्टम में स्टोर हुआ है, उस सिस्टम उस हीट को हम एंथैल्पी कहते हैं, एंड इट कैन बी रिप्रेजेंटेड विद द हेल्प ऑफ एच. So it means that H is equal to E plus PB. Very simple. H is equal to E plus PB. Now what is E? अब कई बार कई बुक में बच्चों E को U लिखा हुआ है, तो आपने प्लीज़ कंफ्यूज नहीं होना है. Don't be confused whether it is E, whether it is U, it is same. Internal energy. So H is equal to U plus PV is written, that is also same. So E is enthalpy, H is enthalpy change. Sorry, H is enthalpy. And when we are going to take the enthalpy change, it will be written as delta H. And you know that delta H is what? It is the heat of product minus heat of reactant. Okay, and on constant pressure, heat of product, enthalpy product or vapor product is, volume product is A. And when some heat is absorbed by reactant, that is HR, ER and BR. And ultimately that HP minus HR will be written as delta H. So that will be written in the form of delta H is equal to delta U plus P delta B. It means that the pressure will remain constant. So this is enthalpy change. Enthalpy change mean enthalpy change होगी जब internal energy change होगी volume के साथ. Okay, after this, second, spontaneity, which is very important. This was the second doubt that after yesterday's video, some of the students asked, and maximum students asked, sir, we don't know about spontaneity, and please tell us again. So what is spontaneity? Basically, if I will take the spontaneity is, as it is given here, the Spontaneous process is an irreversible process and may only be reversed by an external agency. So let me take very simple note down. A process which has a natural tendency to occur either of its own और आफ्टर प्रॉपर इनिशिएशन अंडर द गिवन सेट ऑफ कंडीशन. ऐसे प्रोसेस जो नेचुरल टेंडेंसी से होते हैं, अपने टेंडेंसी से होते हैं, अपनी इंटरनल एनर्जी की वजह से होते हैं, या तो वो खुद अपनी एनर्जी से होंगे या फिर वो जब कोई रिएक्शन स्टार्ट होगा किसी गिवन सेट ऑफ कंडीशन में तो उसको हम स्पॉन्टेनिटी बोलते हैं. दैट स्पॉन्टेनिटी सिंपली मीन द फिजिबिलिटी ऑफ द प्रोसेस. मीन अगर प्रोसेस हो रही है कि नहीं हो रही है. ओके, एंड यू नो वेरी वेल, सपोज if I'll take example of to making a proper tea, until water will not boil, your tea is not you are not telling that tea is prepared. Okay, जब तक चाय उबलेगी नहीं आप ये मानते हैं कि चाय तैयार नहीं हुई है, भले ही सब चीज़ें मिक्स हुई हो. Okay, तो this is the feasibility. Now special condition you are giving: temperature, pressure, volume. This is special condition. So the feasibility of a process is called spontaneity simply. So for example, those spontaneous processes that need no initiation. For example, evaporation of water. There is no initiation need. Evaporation of water will occur. Dissolution of sugar in water. अपने आप घुलती है चीनी पानी में. Reaction between nitric oxide and oxygen to give nitrogen oxide. These are some of the example of spontaneous process without initiation. But some of the spontaneous process that need initiation, that burning of LPG. Until you will not burn, that LPG will not glow. Coal burn to give carbon dioxide when ignited. Okay, so these are spontaneous. And decrease in the enthalpy. Now enthalpy change with spontaneous. This is enthalpy change with spontaneous. Decrease in enthalpy may be the contributory factor of spontaneous, but it is not true for all the cases. Okay, spontaneous reaction may be fast one, but not may be the function of the first one. It can be the, it may be the fast, but it is not the first one. Any two gases can be combined to form a product, but the rate of spontaneous differ from equation to equation. Okay, next is entropy and spontaneity. What is entropy? Now there is introduction of entropy came. Entropy is the degree of disorder or randomness in a system, which is expressed by the thermodynamic. So now see, dear students, if suppose we are going to pass heat. Okay, so what is happening? Suppose I am taking example, we will pass heat on ice. Okay, so what will happen? Ice will slowly inside the molecule, the ice that will move far away. There is more intermolecular space and it will increase the volume, and that particles which is inside the liquid, more heat will provide, it will become gas. Then you know very well, it will start evaporating. Okay, so if most see now, the entropy of this ice is very less than liquid, and entropy of liquid is less than gas. So it means that maximum entropy is in gas and minimum entropy is there in solid. Okay, so in future slide we will study in more detail about the entropy. So let's wait, let me clear this. Okay, so a crystalline solid, or we introduce another thermodynamic function. This is entropy after enthalpy, which is higher the isolation, higher the entropy. The change in entropy accompanying a chemical reaction may be estimated qualitatively, taking some structure in mind. A crystalline solid will have the lowest entropy, whereas gaseous state have highest entropy. I told you. Entropy, like any other thermodynamic function, suppose internal energy we studied, enthalpy we studied, it is a state function and denoted by S. So change in enthalpy is delta S. Whenever heat is added to a system, its molecule lotion increase, causing randomness in a system. Yes, it is true. Whenever heat we are going to pass in any system, so its molecules start moving fast. This heat which is creating that randomness is called randomizing effect. Thus the temperature is the measure of the average chaotic motion of the particle in a system, and mathematically we will represent heat added to a system at lower temperature cause greater randomness than when the same quantity of heat is added to it at higher temperature. Okay, therefore entropy change is inversely proportional to temperature. So it means that delta S is inversely, like we will talk about reversible reaction inversely proportional to temperature. So the total entropy for the system and surrounding of a spontaneous process is given as change in entropy total is equal to change in entropy system plus change in entropy of surrounding. When a system is in equilibrium, the entropy of mixture will be also delta S is equal to 0. So we can say the entropy for spontaneous process increases till it reaches its maximum and its equilibrium, and change in entropy is 0 then. Since entropy is state property, we can calculate the entropy as a reversible process for the following reaction. Okay. Now if delta S surrounding is not equal to 0, delta U is equal to 0 if suppose isothermal condition, but delta S system plus delta S surrounding is not equal to 0. Therefore delta U does not discriminate between reversible and irreversible process, whereas delta S, it means that delta S is the process from which we can find out whether the reaction is reversible or irreversible, but delta U cannot predict this. Okay, so entropy and entropy change. In a simple word, entropy can be thought of as a measure of randomness of system. It is defined as the degree of measurement of the randomness or disorder. Okay, so you can see here liquid have less entropy than, but gas have more entropy, but solid have minimum entropy. So solid gas have entropy of gas as maximum, then liquid, then solid. Like total energy E, total enthalpy H. Similarly, total entropy is also delta S is equal to delta entropy final minus entropy initial, or it can be written as delta S is equal to Q reversible upon T. So entropy may be defined as the property of system which measures the degree of disorder and randomness of the system. It's a Greek word which means transformation, and it is denoted with S. So Clausius, he was convinced of the significance of the ratio of heat delivered at the temperature at which it is delivered. So this entropy shows the second law of thermodynamics. Now entropy introduced the second law of thermodynamics. So dear students, here you need to take care. The entropy of a universe doesn't change for a reversible process. It increases for spontaneous process only, which is irreversible. It means that entropy of universe doesn't change for reversible process. It will only increase for the spontaneous process, as I said. So it means that entropy of universe is equal to entropy of system plus entropy of surrounding, but it should be greater than 0. So when the entropy total is greater than 0, it is showing irreversible nature, which is real and spontaneous also. This is very important relation. Where delta S is equal to 0, it is equilibrium and it shows reversible and ideal situation. Where delta S is smaller than 0, it is non-spontaneous or reversible in nature. Okay, so these are the condition of entropy. Now Gibbs free energy is the third and last, where question can come derive delta G is equal to delta H minus T delta S. Although equation clear everything. Gibbs free energy, what it is? The combination of entropy, temperature and enthalpy, which explain whether reaction is going to be spontaneous or not, mean whether the reaction is going to be feasible or not. Gibbs free energy, the major role of Gibbs free energy is it should tell us about the feasibility. Feasibility means practically ये reaction हो भी रहा है कि नहीं हो रहा है. Okay, that is going to be find out, determined by with the help of this equation, that is delta G. And what is that? The symbol delta G is used to define the free energy of a system. Since this was discovered by J. Willard Gibbs, it is also called Gibbs free energy. Okay, free energy word refer to the amount of energy available to do work. It is referred to the amount of energy available to do work once you have paid your price to entropy. Note that this is not given simply by delta H. It is delta G naught is equal to delta H naught minus T delta S naught. This small naught is standard. When delta G is negative, it indicates that a reaction or process is spontaneous. Now one thing is that we determine spontaneity with the help of entropy. So when the reaction will be spontaneous, when delta S is greater than 0 always. Mean delta S is always plus. Delta S should be plus and delta G should be negative. Okay, this is the condition to give the reaction process as a spontaneous. A positive delta G indicate non-spontaneous reaction which is reversible in nature. It means that meaning is what? The change in free energy of a process equal the maximum work that can be done by the system or a surrounding in a spontaneous process is called free energy, If we will talk about Gibbs free energy, the driving force of a chemical, it is known as driving force of chemical. मीन ड्राइवर कैसे गाड़ी को चला के आगे को मूव कराते हैं किसी चीज़ को. विदाउट ड्राइवर ट्रेन, विदाउट पायलट ट्रेन, aeroplane, or without driver any vehicle cannot be moved forward. So the driving force of a chemical is known as Gibbs free energy. Delta H of the drive toward stability is called enthalpy. Delta S is the drive toward disorder, that is entropy. Delta G is the net driving force of chemical reaction. Delta G value depend upon temperature, pressure and concentration. Delta G should be always smaller than 0, then only reaction is spontaneous, whereas we studied that delta S should be always greater than 0, then it is spontaneous. If delta G is greater than 0, then reaction is non-spontaneous, whereas we studied when delta S is smaller than 0, then reaction is non-spontaneous. It means that delta G is opposite to delta S. Delta G is opposite to delta S. Okay, it means delta S is equal to minus delta G will give spontaneous reaction. This is the overall conclusion. And when delta G is equal to 0, at that time the reaction is equilibrium. So conclusion, Gibbs free energy is a quantity that basically allow us to put the two quantities enthalpy and entropy together in such a way that so that it will arrive at a single function whose sign will determine whether the reaction is spontaneous or not. Okay, the basic definition of Gibbs free energy is delta G is positive, so delta S is negative. You can see the reaction is delta G is equal to H delta H minus T delta S. G is Gibbs free energy, H is enthalpy, T is temperature, S is entropy. Please be aware that the mole of the unit tend to cancel out from the delta S. Predicting spontaneity, negative G means process is spontaneous, positive G mean process is non-spontaneous, and delta G is equal to 0 mean equilibrium. Prediction of reaction, the sign of Gibbs free energy for a given process will depend upon the sign of delta H and delta S also. Delta H will be positive like delta G, whereas delta S will be negative. So we can predict whether the given process will be spontaneous by analyzing the sign of delta H and delta S. So this is the overall conclusion. When delta H is negative, delta S will be positive and delta G will be also negative. It means that delta H and delta G will remain same. When delta H is positive, delta G will S will remain negative and delta G will be positive. Similarly, when delta H is positive, delta S will be positive and delta G sign will be negative or positive. Reaction will be spontaneous if the temperature is very high. Okay, when delta H is negative, delta S is negative, and the reaction will be always opposite and spontaneous if the temperature is very low. So this chart is very important. By this we can clear that what is the conclusion. So dear students, this was all about in this chapter. Now you have 2-3 days. Please do the exercise which I am going to share with you. So with the help of this exercise, you can understand the basic questions of thermodynamics. Okay, so till my next video, take care of yourself, stay home, stay safe, and thanks for watching this. Hope so you enjoyed this video and you understood. Thank you. Have a nice day.